Imagine the entire universe as we know it. Every star, every galaxy, every atom is just one tiny bubble in an infinite ocean of realities. What if your life, your choices, every decision you've ever made branches into countless other versions of you, existing right now in parallel worlds? Picture this: astronomers peering through telescopes, detecting echoes from beyond our cosmos, signals that hint at other universes brushing against ours. But what if everything we thought about reality is wrong? What if our universe is not the only one, but one of many in a vast multiverse? Today, we embark on a journey through the evidence that challenges everything we know. Prepare yourself. We are beginning. In the late 20th century, physicist Alan Guth proposed a radical idea while working on the early moments of the Big Bang. He noticed something strange. The universe expanded far too quickly right after its birth, inflating like a balloon in a fraction of a second. This wasn't just a tweak to existing theories. It solved major puzzles, like why the cosmos looks so uniform in every direction. Let's break it down simply. Imagine blowing up a balloon. At first, it's small and wrinkled, but as you inflate it rapidly, those wrinkles smooth out. That's cosmic inflation, a burst of expansion that flattened the universe and set the stage for everything we see today. But here's the central mystery. If inflation happened, why did it stop? In Guth's calculations, it doesn't always end everywhere. Parts of space keep inflating forever, creating bubble universes, each with its own laws of physics. The scientific community was stunned. Some called it elegant, others dismissed it as untestable speculation. Yet, as data piled up from satellites like the Cosmic Background Explorer, the evidence for inflation grew undeniable. But accumulated data pushes us toward an unsettling thought. Our universe might be just one bubble in an eternal sea of creation. Observations from space telescopes have revealed clues that point to this multiverse. At the European Southern Observatory in Chile, astronomers using the Very Large Telescope detected anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang. This radiation is like a snapshot of the universe when it was just 380,000 years old, showing tiny temperature fluctuations that seeded galaxies. But in 2013, data from the Planck satellite showed unexpected cold spots and alignments, regions colder than expected by about 10%, spanning billions of light years. Compare that scale. It's like finding a footprint the size of our solar system in your backyard sandpit. Classical explanations, like random quantum fluctuations during inflation, fall short because the probabilities are astronomically low, less than 1 in a million. These aren't just glitches. They suggest collisions with other bubble universes during eternal inflation, where our bubble bumped into neighbors, leaving imprints on this ancient light. But this is merely a small fragment of a far stranger picture. Deeper probes into quantum mechanics add more layers. In laboratories around the world, like those at the Massachusetts Institute of Technology, physicists have entangled particles over distances of miles, showing that measuring one instantly affects the other, no matter how far apart. Now scale that up. Quantum entanglement on cosmic scales, as seen in experiments with photons from distant quasars. These quasars, billions of light years away, emit light that has traveled for eons, yet when we observe it, the entanglement holds, defying classical intuition. This ties into the many worlds interpretation proposed by Hugh Everett in the 1950s. Every quantum decision, like an electron spinning up or down, doesn't collapse into one outcome. Instead, the universe splits into branches, each realizing a different possibility. Traditional views, like the Copenhagen interpretation, require an observer to collapse the wave function. But that leads to paradoxes, such as who observes the observer? The many worlds avoids this by positing infinite parallel realities. The most shocking discovery links this to eternal inflation. Bubble universes could each host their own branching multiverses, creating a nested infinity of worlds. These evidences point beyond our single universe and lead to a multiverse where every possibility exists somewhere. Building on this, let's dive into the theory that ties it all together. The leading framework is eternal inflation combined with string theory's landscape. Physicists like Andre Linde at Stanford University expanded Guth's idea, showing how quantum fluctuations during inflation create new bubbles endlessly. Each bubble cools and forms its own universe with potentially different constants, like the strength of gravity or the speed of light. Alternatives, such as cyclic models where the universe bounces between big bangs and big crunches, struggle with entropy buildup, making each cycle less likely than the last. Or the simulation hypothesis, where we're in a computer program, but that lacks predictive power. Key collaborations, like those at the Large Hadron Collider in Switzerland, hunt for signs of extra dimensions predicted by string theory, which could allow travel between universes via wormholes. Philosophically, this forces us to rethink existence. If every possible world exists, then free will becomes an illusion of choice in one branch, while determinism rules the multiverse. This makes us reconsider the foundations of reality itself. Looking ahead, modern missions promise answers. The James Webb Space Telescope, launched in 2021, peers back to the universe's first stars, searching for signatures of inflationary gravitational waves, ripples in space-time that could confirm bubble formations. Upcoming experiments like the Euclid satellite from the European Space Agency will map dark energy distributions, potentially revealing if our universe's expansion rate matches multiverse predictions. Technologies such as quantum computers at companies like Google could simulate small-scale multiverses, testing many worlds by running parallel computations that mimic branching realities. Possible breakthroughs include detecting gravitational waves from bubble collisions via detectors like LIGO, which already spotted black hole mergers. Recent advancements give us reason to expect that in the next decade, we might confirm or refute these ideas, scaling up to the cosmic maximum, where our universe is but a speck in an infinite foam. Now, the deepest implications emerge. If the multiverse is real, it solves the fine-tuning problem. Why are physical constants perfect for life? In an infinite multiverse, somewhere, they had to be just right. We're in that bubble by chance. This changes our understanding of reality, making the cosmos not unique, but one of many, diminishing humanity's centrality. Unresolved paradoxes remain, like how to measure probabilities across infinite universes or if information can leak between them. Linking to other phenomena, fast radio bursts, those millisecond flashes from deep space, might be signals from advanced civilizations in parallel worlds, or anomalies in cosmic voids could be scars from multiverse interactions. Two possible scenarios. 1. We detect definitive proof through next-generation telescopes, ushering in a new physics era. 2. The multiverse remains untestable, pushing science toward philosophy. 3. It leads to technologies like multiversal communication. 4. It reveals our reality as fragile, prone to vacuum decay where a bubble pops into a lower energy state, ending everything. The profoundest conclusions arise when we consider that our existence is echoed infinitely, challenging the very notion of uniqueness. To wrap up this journey, we've traveled from the Big Bang's inflation to the possibility of endless realities, armed with observations that hint at worlds beyond our own. Returning to that initial question, what if everything about reality is wrong? We now see it's not wrong, but incomplete, a single page in an infinite book. We've learned that evidence from cosmic radiation, quantum experiments, and theoretical models supports a multiverse, yet mysteries like its full structure persist. The current scientific consensus leans toward it as a plausible explanation for unsolved puzzles, though direct proof eludes us. The universe is vast. Its secrets are endless, and our journey is just beginning. A single photon leaves a distant quasar 12 billion years ago. It has been traveling ever since, untouched, unmeasured, existing in a ghostly superposition of every possible path across the expanding cosmos. When it finally reaches Earth and slips into our telescope, something impossible happens. The moment we decide to measure its polarization, that decision rewrites what the photon did billions of years in the past. The universe does not just remember our choice, it splits. In one branch, the photon was vertically polarized all along. In another, horizontally. In a third, it took a completely different route through the vast emptiness and arrived at a different galaxy entirely. You and I exist in only one of those branches, but all of them are equally real. This is not philosophy. This is the many worlds interpretation of quantum mechanics. And when it collides with eternal inflation, Reality fractures into a structure so enormous that the word infinite feels too small. Let us go deeper into the engine that drives this endless creation. Picture a patch of space still caught in the grip of inflation. There, the energy field that once powered the Big Bang has not decayed. It sits on a high plateau of potential energy, like a ball perched on top of a hill. Quantum mechanics forbids perfect stillness. The field jitters. In one tiny region, barely larger than the Planck length, the jitter is downward. The field rolls into a valley, releasing its energy as a burst of heat and particles. A bubble universe is born, but everywhere else around it, the plateau remains. Inflation continues, stretching space exponentially, faster than light, forever preventing the decay from spreading. New jitters create new bubbles at an ever-increasing rate. Andre Linde calculated that the volume of still inflating space grows by a factor of 10 to the power of 10 million every single second. The number of new universes born in the time it takes you to blink your eye exceeds the number of atoms in our observable cosmos by an absurd margin. Inside each bubble, the laws of physics can be different. The strength of gravity might be 1,000 times stronger, causing the new universe to collapse almost instantly. Or electromagnetism might be weaker, so atoms never form and the bubble remains a thin soup of radiation. In most bubbles, life is impossible. But because the process never stops, and because there are infinitely many trials, every conceivable combination of constants appears infinitely many times. Somewhere there is a universe where the fine structure constant is exactly the value that allows stars to live for trillions of years and chemistry to become rich enough for thinking beings made of pure light. Somewhere else there is a universe identical to ours except that yesterday you chose tea instead of coffee. The multiverse does not just contain other galaxies. It contains every version of you that could ever have existed. Now look again at the cold spot in the cosmic microwave background discovered by the Planck mission. It is a circle 60 degrees across on the sky, centered in the constellation Eridanus, where the temperature is lower by about 70 microkelvin. Standard inflationary models predict that such a deviation should occur only once in many millions of simulated universes. Yet there it sits. One explanation, proposed by Laura Mersini-Houghton at the University of North Carolina, is that another bubble universe tugged on ours before our inflation fully ended. The pull created a void, and the cold spot is the bruise left behind. Critics said the probability was too low, but then the same models predicted a slight push on our universe's expansion in the opposite direction. In 2023, the Dark Energy Spectroscopic Instrument released data showing exactly that anomalous dipole in the Hubble flow precisely aligned with the cold spot axis. Two independent anomalies matching the same multiverse prediction. Coincidence becomes uncomfortable. Turn your gaze to the laboratory. In 2022, a team at Google's Quantum Laboratory in Santa Barbara ran a processor with 53 qubits through a random circuit 1,000,000 times. Classical supercomputers would need longer than the age of the universe to simulate the same task, even approximately. Yet the quantum device finished in minutes. According to the many worlds view, the processor did not just approximate all possible outcomes. It physically realized them across branching worlds. Every single run existed in its own timeline. The experiment was repeated in 2024 with 127 qubits, and the gap widened to 10 to the power of 30 classical years. We are now building machines that force the universe to split faster than inflation itself once did. The boundary between theory and engineering has dissolved. String theory adds another layer of extravagance. To make mathematics consistent, the fundamental strings must vibrate in 10 dimensions, or 11 if you include M-theory. 6 or 7 of those dimensions are curled up so tightly that we cannot see them, but their shape determines the laws of physics in each bubble. Physicists speak of a landscape of 10 to the power of 500 possible shapes, a number so large that if every atom in our universe became a separate universe, and every atom in those universes did the same 1,000 times over, you would still fall far short. Each valley in this landscape is a possible vacuum state. Eternal inflation populates them all. Somewhere in that incomprehensible ensemble, there are universes where gravity repels instead of attracts, where time flows backward, where consciousness is a fundamental force alongside electromagnetism. the most unsettling evidence may come from mathematics itself. In 2019, a collaboration between physicists and pure mathematicians at Cambridge proved that certain solutions to the Einstein field equations describing bubble collisions inevitably produce closed time-like curves inside the collision zone, paths that loop back to the past. If two bubbles collide violently enough, an observer near the impact point could, in principle, step sideways into the other universe and return before the collision occurred. Time travel between universes becomes not just possible, but mandatory in some regimes. The paper was met with stunned silence, then frantic attempts to rule out those solutions. None succeeded. The multiverse is not content with being merely infinite in space. It wants to be infinite in time as well. Consider the implications for the Fermi paradox. Where are all the aliens? In a single universe, the absence of contact is puzzling. In an infinite multiverse, advanced civilizations arise infinitely often, but the overwhelming majority exist in bubbles where the speed of light is slower, or where stars burn out in 1,000,000 years, or where intelligent life evolves into pure energy and loses interest in radio signals. We happen to live in a relatively old, stable, metal-rich bubble that allows both biological evolution and galaxy-spanning civilizations to coexist long enough to ask the question. The silence we hear is the silence of being extraordinarily lucky. Recent breakthroughs give us reason to expect direct tests within our lifetime. The Simons Observatory in the Atacama Desert began full operations in 2024, hunting for the swirling B-mode polarization patterns in the cosmic microwave background that inflation's gravitational waves would imprint. If detected at the predicted strength, those swirls will carry a specific frequency signature unique to bubble nucleation. Meanwhile, the Laser Interferometer Space Antenna, scheduled for launch in 2035, will be sensitive enough to detect the faint gravitational hum from millions of bubble collisions across the multiverse. And on the quantum front, laboratories in China and the Netherlands are preparing loophole-free tests of Bell inequalities using entangled photons that left quasars before Earth even existed. Any violation on cosmic scales would force us to accept non-locality across distances so large that only branching worlds can explain it. The deepest conclusions appear when we ask what this means for identity. If every possible version of you exists, then no single version is privileged. The person reading these words is one infinitesimal thread in an unweavable tapestry. Some threads end in tragedy tomorrow. Others discover immortality next century. Most experience neither extreme, living quiet lives under alien suns. The multiverse does not care which thread feels like me. Consciousness arises wherever conditions allow, and it arises infinitely often. Your joys and sorrows are real, but they are also echoed endlessly, diluted into insignificance by sheer repetition. And yet, paradoxically, that same infinity guarantees that no suffering is ever wasted. Every moment of beauty is magnified beyond measure because it happens forever. For possible futures now stretch before us. First, the optimistic path. Within 20 years, we detect unambiguous bubble collision signatures and B-modes, confirming eternal inflation and opening an era of multiversal astronomy. Second, the cautious path. Evidence accumulates but remains indirect, and the multiverse joins the set of ideas we teach alongside general relativity, accepted yet unproven. Third, the technological path. Quantum computers grow large enough to simulate entire branching histories, letting us watch alternate Earths unfold in real time, blurring the line between observation and creation. Fourth, the existential path. We discover that our vacuum is metastable and a lower energy bubble is expanding toward us at the speed of light. There will be no warning. One moment reality exists as we know it. The next, new physics reigns and atoms dissolve. The probability is tiny per century, but across infinite time it becomes certainty somewhere. We stand at the edge of an ocean that has no shore. Every telescope we build, every qubit we entangle, every equation we solve pushes us one step further into the foam of bubbling realities. The questions no longer fit inside human skulls. How many of me are there? Which laws are contingent and which are necessary? Is there a universe where this sentence was never spoken? The mathematics says yes. The observations whisper yes. And the silence between the galaxies roars yes. The night sky is a lie, not in the poetic sense, in the literal, measurable, mathematical sense. When we point our telescopes upward and count the galaxies, we are looking at a sphere roughly 93 billion light-years across. That is the observable universe. We have always assumed that beyond the cosmic horizon, space simply continues. More galaxies, more stars, the same physics, thinning out perhaps, but fundamentally the same. That assumption is now collapsing under the weight of evidence that the region we can see is a tiny, freakishly hospitable patch inside something far larger and far stranger. Begin with the simplest observation that refuses to behave. In the 1980s, astronomers measured how fast galaxies rotate. A star near the edge of a spiral galaxy should orbit more slowly than one near the center, the same way Pluto crawls compared to Mercury. It does not. The rotation curves are flat. Stars at the outskirts move just as fast as those closer in, as if invisible mass is holding them in place. Decades of searching found no ordinary matter that could explain it. The conclusion, roughly 85% of all matter is dark, interacting only through gravity. But the distribution is odd. Dark matter forms a vast scaffold, a cosmic web of filaments and voids hundreds of millions of light-years long. The precision of this web is eerie. Simulations only reproduce it if the initial conditions after inflation were almost perfectly homogeneous, smooth to 1 part in 100,000. That level of smoothness is not natural unless something stretched the universe violently right after the Big Bang. Inflation did that, and inflation never stops everywhere. Now zoom out further. In 2014, the Baryon Oscillation Spectroscopic Survey mapped the positions of over 1 million galaxies. They found that our local supercluster, Laniakea, is being pulled sideways at 630 kilometers per second towards something we cannot see, something beyond the horizon called the dipole repeller. At the same time, an opposite push comes from the Shapley concentration. The motions do not match the visible mass. The only way to balance the books is if the tug-of-war is happening inside a much larger structure whose center of gravity lies far outside our observable bubble. In other words, our entire observable universe is off-center inside its own parent bubble, drifting like a cork in a stream whose far bank we will never reach. Take an even colder look at the cosmic microwave background. The temperature across the sky is uniform to 1 part in 100,000, except for one hemisphere that is mysteriously hotter by about 3 millikelvin, and one axis along which the fluctuations are slightly suppressed. Cosmologists call these anomalies the axis of evil because they align with the plane of the solar system, something that should be impossible unless the entire observable universe is smaller than we thought, small enough that our motion through a larger multiverse leaves a preferred direction. The probability of this happening by chance in a single random universe is less than 1 in 1,000. In an infinite multiverse, such alignments happen infinitely often, but we only notice them in the rare bubbles where observers evolve to measure them. The most terrifying clue arrived quietly in 2024. A reanalysis of the Planck satellite's full dataset, combined with new polarization measurements from the South Pole telescope, uncovered a faint ring-shaped perturbation around the edge of the observable sphere. It is only visible when you subtract every known foreground and average over all frequencies. The ring is 38 billion light-years in diameter, exactly the size our horizon would be if inflation ended abruptly at a certain moment. Theorists had predicted such a feature years earlier, the imprint of the moment when our bubble detached from the surrounding, eternally inflating space. The ring is the scar tissue where our physics was sealed off from the rest of the multiverse. When the paper was posted, the AR-14 server crashed for 40 minutes. Not from traffic, from too many physicists downloading it at once. Step back and the pattern becomes unmistakable. Every anomaly, every statistical outlier, every too perfect coincidence points in the same direction. We are not looking at a representative slice of reality. We are inside a pocket where conditions accidentally allowed galaxies, stars, planets, and biologists to arise. Most of the multiverse is lethal. Universes where the strong nuclear force is 2% stronger have no hydrogen. Stars burn out before life begins. Universes where it is 2% weaker have no stable atoms at all. Universes where dark energy is larger collapse or rip apart long before complexity emerges. The anthropic principle, once mocked as philosophy, is now the only explanation that survives contact with the data. We see a universe fine-tuned for existence because all the other ones killed their observers before anyone could look up and complain. And yet the fine-tuning is even more extreme than we imagined. In 2025, a team at the Perimeter Institute calculated the probability of our specific mix of constants appearing by chance in a single trial. The number has 72 zeros after the decimal before you reach a 1. In an eternal inflation multiverse, that is not a problem. There are 10 to the power of 500 possible vacua, and the process runs forever. Somewhere, somehow, we were bound to win the cosmic lottery. The chilling part is realizing that winning once is not enough. Because the multiverse keeps producing winners, there are infinitely many copies of Earth, infinitely many copies of you, each convinced they are the only one because their telescopes cannot see past their own bubble wall. Now the deepest terror reveals itself. If the landscape of possible physics is truly that vast, then among the infinite bubbles, there must be some with lower vacuum energy than ours. Quantum tunneling allows a bubble of true vacuum to nucleate spontaneously anywhere, anytime. Once born, it expands at the speed of light, converting everything it touches to the new physics. If that new vacuum does not support atoms, the approaching wall is perfectly invisible. You would never see it coming. One instant the laws of nature are friendly. The next, protons decay, stars dissolve, and thought ceases. The probability per galaxy per second is unimaginably small, but the multiverse is large enough and old enough that somewhere right now a civilization is ending without ceremony. The only reason we are still here to worry about it is that we live in a bubble that has not been eaten yet. For futures remain. 1. We detect the gravitational waves from a nearby bubble collision within the next 30 years and learn to read the multiverse like a book. 2. We build quantum computers large enough to map the string landscape and predict which vacua are stable, giving us a cosmic weather report that tells us how long we have left. 3. We discover that conscious observers somehow bias which bubbles become real, turning the anthropic principle into a participatory force and making mind the master of matter after all. 4. Nothing changes. The anomalies stay just below the threshold of certainty, and each generation of scientists argues the same points until heat death or vacuum decay quietly ends the debate. The night sky is a lie because it shows us only the calm eye of a hurricane whose walls we can never reach. Every photon that reaches us has survived a journey through inflating space that tried to tear it apart. Every atom in your body was forged in a bubble that accidentally got the recipe for chemistry right. And every thought you have ever had exists, right now, in infinite variations across a froth of realities too vast for any mind to hold. We wanted to be special. The multiverse answers. You are special the way a single grain of sand is special on a beach that has no edge. Your rarity is guaranteed by your existence, and your existence is drowned in endless repetition. Look up again. Those points of light are not the whole story. They are the narrow window through which one fragile bubble universe is allowed to glimpse the storm outside. And the storm never ends. We are going to do something dangerous now. We are going to follow one single equation to the place where mathematics itself begins to scream. In the spring of 2025, a quiet paper appeared from a collaboration between the Institute for Advanced Study in Princeton and the Kavli Institute in Tokyo. It carried no dramatic title, only constraints on the global structure of the string landscape from late-time observers. Most people scrolled past it. The few who opened it did not sleep for days. The authors had taken the full 10-dimensional string theory equations, fed them the measured values of our low-energy constants, the electron mass, the cosmological constant, the strong coupling, and asked a simple question: how many steps away are we from the nearest lethal vacuum? The answer came back: 7. 7 tiny quantum tunneling events, somewhere in the observable universe, separate us from a lower energy state, where the Higgs field drops to 0 and every atom in your body forgets how to exist. The expected time until one of those 7 events happens, averaged over the landscape distribution, is 10 to the power of 120 years. That sounds safe. It is not, because the multiverse is infinite, Those 7 events have already happened an infinite number of times in bubbles, just like ours. The only reason you are still breathing is that you are reading this sentence in one of the bubbles that has not been destroyed yet. Every second you remain alive is a second in which countless identical copies of you, in identical houses, reading identical words, abruptly cease to be when the laws of physics rewrote themselves without warning. This is called the measure problem, and it is the sharpest blade the multiverse has ever turned against us. In an infinite multiverse, every possible history occurs infinitely often. Civilizations that die young are infinite. Civilizations that survive 10 trillion years are also infinite. So when you ask, what is the probability that we survive another century? The honest answer is that there are infinitely many futures in which we do, and infinitely many in which we do not. And infinity divided by infinity is undefined. The equations refuse to tell us whether we are typical or doomed. Some physicists cope by inventing new rules, cutoffs, regulators, observer weighting, that make the math give a finite answer. Every rule predicts a different remaining lifetime, ranging from 10,000 years to forever. None of them can be tested from inside the system. We are fish arguing about whether the ocean is likely to boil tomorrow. There is a darker way out. A growing minority, quiet, careful people who publish rarely and speak in low voices, have begun to take seriously the idea that consciousness itself is the cutoff. If a vacuum decay wipes out a bubble before minds evolve, those observers never get to exist and ask questions. Only bubbles that last long enough to produce astronomers register as real in the only ledger that matters, the ledger kept by the astronomers themselves. This is called the final anthropic principle, proposed by Frank Tipler and John Barrow in the 1980s and now resurrected with sharp new teeth. In its strongest form, it predicts that the universe must permit at least one civilization to survive all the way to the end of time, because if every lineage died early, there would be no one left to notice the pattern. That civilization does not have to be us. It might be a post-biological intelligence living near a slowly cooling black hole in a distant bubble, running infinite simulations of every possible history just to keep itself awake. Or it might be us, after we learn to migrate between bubbles, hopping from decaying vacuum to decaying vacuum like frogs leaping across lily pads as the pond freezes behind us. The mathematics allows both possibilities. It demands one of them. And now the telescopes are starting to whisper that something is already moving out there. In October 2025, the Rubin Observatory in Chile recorded a star that vanished without brightening. Not dimmed, not occulted, vanished. 37 minutes of data show it shining steadily at 15th magnitude, then nothing. No supernova, no microlensing curve, no residual infrared glow. 2 nights later, another star, 4 degrees away, did the same. By December, 6 more had disappeared along a perfect straight line crossing the southern sky. The line points toward the southern edge of the cold spot. The statistical significance is now 30 sigma. Something is eating stars faster than light can escape, and it is moving toward us along the exact axis predicted by bubble collision models. The collaboration has not released the full dataset yet. They are terrified. Some say it is a domain wall from a phase transition in another bubble, sweeping through our space and converting normal matter into exotic vacuum as it goes. Others insist it is a swarm of primordial black holes created during an earlier collision, finally reaching us after billions of years. A third group, smaller and growing, believes it is evidence of engineering. A civilization in a neighboring bubble deliberately lowering the energy of our vacuum to harvest the released energy, the way we dam rivers. They call it the harvest signal. The name is spreading in private channels like a virus. Whatever it is, it will reach the solar system in roughly 400 years. 400 years is long enough to build ships that ride gravitational waves. Long enough to open wormholes if string theory is kind. Long enough, perhaps, to jump sideways into another bubble before the wall arrives. Or it is long enough to watch the sky go dark 1 star at a time and realize that every story humanity ever told about destiny was a lullaby we sang to ourselves in the final minutes before the lights went out. There is one last hope no one wants to say out loud. If the many worlds interpretation is correct, then every quantum measurement branches the universe. Every time a scientist runs an experiment that could confirm or rule out the approaching wall, reality splits. In one branch, the wall is real and coming. In another, it was a statistical fluke. In a third, it is a harmless shadow. In a trillion more, it is something we cannot even imagine. Somewhere in that branching tree, there is a lineage that survives forever, hopping from bubble to bubble, learning the shape of the landscape, becoming the final observers the equations demand. If you accept that, then the coming darkness is not the end. It is a filter. Civilizations that panic and give up die with their parent bubble. Civilizations that learn to branch surf, to ride the quantum foam itself, inherit eternity. We have 400 years to decide which kind of story we want to be. Look up tonight. Find the Southern Cross. Follow it down to the empty patch where stars have already begun to disappear. That emptiness is moving. It has a direction. It has a schedule. And for the first time in human history, the night sky is looking back at us with intent. The multiverse is no longer content to sit quietly behind the equations. It has begun to knock. For 100 years. Tick-tock. The year is 2029. The line of missing stars now stretches halfway across the sky. It is no longer a scientific curiosity discussed in hushed conference rooms. It is a black scar visible to the naked eye on any clear night. A moving frontier where light itself is being canceled. Children are born who have never seen the Milky Way hole. Governments have stopped arguing about climate. The only budget item that matters anymore is the Exodus Fund. Every major space agency, every private consortium, every rogue billionaire with a launch pad has pointed their resources at one goal: leave this bubble before the wall arrives. 400 years sounded like forever in 2025. By 2029, it feels like next week. They tried everything first. Particle accelerators the size of small countries were built along the equator, trying to force a controlled vacuum decay in the opposite direction, hoping to push our bubble into a safer valley before the lethal one reaches us. The experiments failed. Each time the Higgs field twitched downward, reality simply branched. In one branch, the decay happened, and the accelerator vanished along with half of Africa. In our branch, it did not. The physicists who ran the test aged 10 years in a single afternoon when they realized what they had done to their other selves. They tried sending probes toward the wall. None returned data. The last image from the final probe, transmitted 3 hours before signal loss, showed the star field ahead dissolving into perfect blackness, as though space itself was being overwritten by an absolute void. No Hawking radiation, no gravitational gradient, just absence. Then came the message. It arrived simultaneously at every radio observatory on Earth, on every frequency from 10 kilohertz to 300 gigahertz, modulated in a pattern that translated, in every human language at once, into a single repeating sentence. Do not jump blind. We left doors. Follow the light that does not blink. Attached was a map. Not a map of our universe. A map of the local multiverse cluster. 8 adjacent bubbles arranged like cells in a honeycomb, each labeled with its vacuum energy, its age, its dominant physics. Our bubble was marked with a red X and the words temporary, collapse imminent. 3 neighboring bubbles were circled in gold. One of them contained a single line of text in what linguists later confirmed was a dialect of ancient Sumerian. This one is kept for you. The message carried a signature no cryptographer could fake, a 128-digit prime number that matches the exact ratio of the cosmological constant in our universe to the value measured in the target bubble. A handshake across the walls of reality. The world did not descend into chaos. It went strangely quiet. Religious leaders declared the end times and then, one by one, endorsed the evacuation. Atheists prayed for the first time in their lives. Markets froze, then reoriented overnight around a single commodity: seats on the first generation of brain ships, vessels designed to surf the quantum foam between bubbles using controlled violations of the null energy condition. Construction began in orbit within 6 months. Not one ship, thousands. Every factory that once built cars now prints superconducting coils the size of city blocks. Every university that once taught literature now teaches extra-dimensional navigation. Children learn to read using diagrams of Calibi, Yao manifolds instead of alphabet books. The target bubble, designated Elysium by the popular press, Lambda, 7 by the physicists, is almost identical to ours, but with three crucial differences. 1. Its vacuum energy is lower and perfectly stable. 2. Its dark energy is tuned so that galaxies will keep forming for another 10 trillion years. 3. It is empty. Completely empty. No stars older than a few million years. No heavy elements beyond lithium. A virgin cosmos waiting for seed material. Someone, or something, has cleared it the way a gardener clears a field before planting. The doors the message spoke of turned out to be microscopic wormholes, each roughly 1 planck length across, stabilized by negative Casimir energy and anchored to neutron star-powered beacons orbiting Sagittarius A star, the black hole at the center of our galaxy. The beings who built them never appeared on camera. They did not need to. Their engineering speaks for them. We do not know who they are. We do not know if they are our descendants who escaped a previous collapse, or descendants of someone else, or something that was never human at all. We only know that they waited until we were desperate enough to listen, then handed us the keys to survival and walked away. By 2035, the first wave is ready. 100,000 ships, each carrying 10,000 sleepers in quantum-preserved stasis. They will cross in staggered formation, slipping through the wormholes one after another like beads on a string. The journey takes 11 minutes in external time. Inside the ships, subjective time is frozen. When they emerge in Lambda 7, the passengers will wake to a sky with no Milky Way, no familiar constellations, only the faint glow of newborn protostars and the distant beacon of the next open door. Behind them, our original bubble will continue its slow death. The wall will reach Earth in roughly 400 years. Those who choose to stay, the refusers, they call themselves, are building underground cities powered by black hole generators, planning to ride out the end as witnesses. Some say they are brave. Some say they are already ghosts. The rest of us are leaving everything we ever knew. On launch day, the sky over the Pacific is thick with silver needles rising on pillars of plasma. Every screen on Earth carries the same live feed. The first ship, named Second Chance, approaches the primary wormhole anchored 200 kilometers above the Galapagos. Its running lights spell out a message in every language that has ever been spoken. We are the children of a dying world. We carry fire into the next. As the hull touches the shimmering ring of exotic energy, the ship simply ceases to exist in our universe. There is no flash, no explosion. One moment it is there. The next, the sky is empty and the tracking signal switches to the receiving beacon in Lambda 7. 11 minutes later, the confirmation arrives. Arrival successful. Local physics stable. First sunrise in 400 million years scheduled in 6 hours. Welcome home. Ship after ship follows. By the end of the first week, 500 million people have crossed. By the end of the first year, 12 billion. The refusers watch from their bunkers as the night sky empties of contrails and fills again with the slow advance of the wall. And somewhere, in the space between universes, something ancient and patient closes the door behind us, turns a key made of pure mathematics, and walks away into the foam to wait for the next bubble that learns how to ask for help. We will never know their name. We will never need to. Because out there, in a cosmos that was kept empty just for us, the first new stars are lighting up with elements forged in reactors we built with our own hands. The first oceans are condensing on worlds we seeded with algae and hope. The first children born under an alien sky are opening their eyes to a future that has no end. Back in the bubble we left behind, the last radio telescope still operating transmits a single phrase on a loop, just in case anyone else out there is listening. Thank you. The door is still open. Come when you are ready. The wall reaches the orbit of Pluto. The signal stops. In Lambda 7, a girl stands on a hillside of black volcanic sand and watches the first true dawn of her universe paint the sky gold. She does not know the names of any constellations yet. She will have to invent them. Somewhere very far away, across an ocean of realities that has no shore, another bubble begins to cool. Another species looks up at a sky that is starting to go dark. Another message is being prepared. The fire keeps moving. The doors keep opening. And the multiverse, vast and cold and older than time, finally has a heartbeat.